the radius of the circle R is equal to 1.22 meter. So area enclosed by up to which correct significant figure. So the area is how many significant figures? The significant figures are 3 in the case of radius is given data. So now this is the circle. So what is it is a radius is R. So area of the circle is equal to pi r square. So we know that is a value of pi. Pi is equal to 3.142 into r square is how much? 1.22 meter square. So after the simplified, so we get the answer 4.67782 meter square. So now the final result is the final result with the correct significant figure is so let's see the correct significant figure. So 3 radius is given, 3 significant figure. So this is 1, 2, 3. So after this one it is a 7 above the number, okay, above the 5. So above the 5 andre you go to the next digit, okay, next digit. So which is the 7 agimele next digit yavadu barutte illi 8. The final answer is 7.6. okay, so 7 ide, that becomes 8 meter square. This is the correct answer. So that is 4.68 is the correct answer. That is answer D is a correct answer for the first question. The equation P plus A divided by B square into B minus B is equal to constant. So then what is the unit of A? The question is asked. So then P plus A by V square is equal to constant. So then A divided by V square is equal to P. So the question is asked A unit, then A is equal to PV square. Then A is equal to P. P is force divided by area into V cube, volume, that is square, sorry. So then A is equal to the, okay, options are given in the CGS system. So then you have to put the CGS system, okay, CGS system. So then what is the force unit in CGS system? Dyne is the unit of the CGS system. Area is centimeter square into centimeter cube whole to the power of square. So after the simplified, A is equal to dyne centimeter 4. So which is the matching for this solution? That is option B. Option B is the matching for this answer. When the number 6.03587 is rounded off up to the second decimals. Okay, so now how to solution for this one? Second decimal means this is the decimal point, this is 1, this is 2. How to round up this number? 6.0. So 3, the next digit is 5. Okay, so 5 is the digit. That means according to the rule 1, so 0, 3, it is 4. Okay, 6.04, that is option B is the correct answer for this. Energy, momentum, force are chosen the fundamental units. The mass of the new system can be expressed. Okay, the mass of the new system is expressed. Okay, let's see the solution. So LHS side is mass, RHS side that is energy, momentum, force. We don't know power. You have to assume that this power is X, this power is Y, and this power is Z. Okay, so this is called as equation number 1. Okay, so we have to find out one by one. First one, energy. Okay, energy is equal to work. Okay, so work, that is equal to force into displacement formula. So force dimensions formula, m1 l1 acceleration minus 2. Then displacement is L. L is the displacement. So then after the simplified, energy is equal to m L 1 plus 1 2 T minus 2. So this is the dimensional formula for energy. Then P is equal to product of mass into velocity, that is equal to m, velocity is meter per second, L T minus 1 meter per second. Then force is equal to mass into acceleration, so then that is equal to m L T minus 2. So now put all the dimensions formula in equation number 1. So then equation number 1 becomes that is mass is as it is, that is equal to, okay, E dimensions formula m L2 T minus 2 whole to the power of x. Then L dimensions formula m L T minus 1 whole to the power of y. Then force dimensions formula m L T minus 2 whole to the power of z. So now that is in the LHS side, m is as it is, that is equal to. Now according to the dimensions homogeneity principle, so m nodi, so let's see, m 1 into x, then m 1 into y plus y, then 1 into z plus z. So that is m, it is power is x plus y plus z. Then L, so L dimensions formula 2 into x, 2x. Then 1 into y plus 1. Then 1 into z plus z. Okay, mass into acceleration. Okay, let's see. Then T to the power of minus 2 into x, minus 2x. Then minus y, then minus 2z. So comparing the powers, so m it is 1, so x plus y plus z, m, this is m, so x plus y plus z, that is equal to 1. Then 2x plus y plus z, that is equal to L to the power nothing is there, that is 0. Then minus 2x minus y minus 2z, that is t to the power of nothing is there, that is 0. Okay, so this is the equations, equation 2 and equation 3. This is equation number 4. So now after the simplified, okay, so after the simplified we get the answer. So equation simplified with this one, equation 3 and 4. So equation 3 and 4 are simplified ಮಾಡಿ equation 3 and 4 simplified equation 3 and 4. So we get minus 2x plus 2x get cancelled, this one cancel, minus z is equal to 0, then that is a z value is equal to 0. Then so equation second and 3 simplified, equation second and 3, equation second and 3, equation second and 3. So y cancel, that is x is equal to 1. Then put x and z value in equation number second. So then y is equal to 2. So now put the x, y, z values on equation 1, then m, that is e to the power of 1, p to the power of 0, p to the power of 2, then f to the power of z, that is 0. So z is equal to 0, then x is equal to that is value is, this one is cancelled, minus x is equal to, that means it is minus 1, sorry, minus 1. So this is a minus 1. So that is the final answer is m to the power, that is m dimensions formula, e to the power of minus 1, p to the power of 2 and f to the power of 0, that is f to the power of 0, and that means 0. So e to the power of minus 1, p to the power of 2. So which answer to matching for this solution? Which answer? Let's see, e to the power of minus 1 and p square, that is option C is the correct answer for this question. The Richardson's equation is given. So this is the Richardson's famous equation. The dimensions formula for AB square, okay, is the same as. So let's see the first one. I is equal to 80 square exponential function of minus b divided by kt. So then, so this is I is equal to 80 square. This is the 1. Okay, this is exponential function. This is the exponential function. So that exponential function, that is b is equal to kt. Then the question is asked AB square. AB square is equal to how much? So then after the simplified, that is a is equal to what? A is equal to I divided by T square, then B is equal to KT. So then AB square, put the value of A value is AB square, that is A value is I divided by T square into D square is K square T square. Now that is T square get cancelled. The final answer is I into K square. So I into K square, which is the answer is matching to this one. That is option C is a matching to the this solution. Let's see. That is a option C. That is IK square is matching. That is answer C is the correct answer for this question.
Hey there! Subscribe to my channel and also press this bell icon so you can get latest video notification.
So turpentine oil flowing through the tube of length L and radius R. The pressure difference between the two ends of the tube is P. So let's consider this is the tube. Okay, in this tube, so this is the L is the length of the tube and R is the radius. The pressure difference between the ends of the tube, that is the pressure difference is delta P is the pressure difference between the tube. Sorry, P, not for delta P. P is the pressure difference between the tube. The viscosity is given. This is the viscosity. Then V is the velocity of the oil at a distance x from the axis of the tube. Okay, so this is the oil. The distance is x. So then the dimensional formula for eta. So now eta is equal to, so P means pressure, it is given, P is the pressure. So the dimensional formula for pressure is equal to force by area, that is equal to ml T minus 2, mass into acceleration, then it is L square. So after the simplified, that is ml minus 1 T minus 2, that is the pressure. Then R is the what? Radius, distance. So now put the values. P value is L minus 1 T minus 2. Then R square both are distance, that is L square. Then divided by 4 is a constant, velocity dimensional formula meter per second. Then length, it is a L. So the dimensional formula for eta is equal to m L to the power of minus 1 plus 2 1 1, so 1 plus 1 2 minus 2, then T to the power of minus 2, this is plus 1, that is minus 1. So the dimensional formula for eta, coefficient of viscosity, is given, that is m L to the power of minus 1 T to the power of minus 1. So which is the matching for this solution? m1 L minus 1 T minus 1, that is option D is the correct answer for this question. 1 centimeter on the main scale of the vernier scale is divided into 10 equal parts. So let's see the solution. This is the main scale. This is the main scale. So this is the vernier scale. This is the vernier scale. Vernier scale. The vernier scale is divided into 10 equal part. 10 equal part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is a 10 equal part. If the 10 divisions on the vernier scale coincide with 8 small divisions on the main scale, so main scale it is 8 division. So 8 division means 1, 2, 3, 4, 5, 6, 7, 8. 8th division, this is 10. So usually general cases, the main scale, how it is made? This is the main scale, this is the vernier scale. The 9th division of the vernier scale is coincide with the 10th division of the main scale division. So this is the general case. Okay, in general case, in general, this is the structure of the vernier calipers. But in this problem, this is the 8 is coincide with the 10th division. So what is the least count of the vernier calipers? We know that the formula for least count is equal to 1 main scale division minus 1 vernier scale division. So this is the formula for least count. So now you have to put the value, that is the least count is equal to, so main scale division. So the main scale division, so 8, look at this one, 8 small divisions. So that is a 1 main scale reading is 1 minus, okay, 1 MSD minus 8 by 10 MSD. Okay, so then the final answer is equal to, the least count is equal to, so that is 10 minus 8 divided by 10. So that is the least count is equal to 2 by 10. This is in millimeter. Because why 8 small divisions? Okay, small divisions. So that is millimeter, but the answer is in centimeter. Okay, so then after the simplified we get, so 0.2 mm, millimeter. Then how to convert millimeter into centimeter? The least count is equal to 0.2 into 10 to the power of minus 1 centimeter. So the final answer is 0.02 centimeter. So which option is to matching for this one? 0.02. That is the option B is a correct matching for this answer. Find the dimensional formula for gas constant. So P is the pressure, volume, number of moles, temperature. So the equation is PV is equal to nRT. So let's see the solution. So the equation is PV is equal to nRT. So then R is equal to PV divided by N into T. So this is called as equation number 1. So now one by one you have to find out. P means pressure. Pressure is equal to force by area. The dimension formula for force is M L T minus 2 divided by L square. So then after the simplified, the m L minus 1 T minus 2. So this is the dimensional formula for pressure. Then volume is L cube. Then so N, number of moles. Okay, N is the number of moles. Number of moles dimensional formula is mole. Then T is the temperature. Temperature dimensional formula is theta. So now put all the values. Okay, so put all the values on this equation. So then R is equal to P dimensional formula is m L minus 1 T minus 2 into V is L cube, then divided by the dimensional formula for N is mole. Then the dimensional formula for temperature is theta. So now the gas constant is equal to m1 L, so minus 1 plus 3, that is minus 2 T minus 2, that is per mole per theta. Okay, so this is the dimensional formula for gas constant. So after the solution, which is the answer is matching for this question. So m1 L minus 2, okay, not for plus 2, this is plus 2, okay, plus 2. So m1 L plus 2 T minus 2, okay, m1 L2, this option is not matching, m1 L2 T minus 1 T minus 2 theta minus 1 mole per minus 1, that is option B is the matching. So sorry, option D is the matching for this. So D is the correct answer for this question. Okay, next one, calculate angle subtended by the periphery area 1 centimeter square. So solid angle. So solid angle means, so let's take, this is the solid. Okay, this is the solid. You have to angle. So this is the solid angle. The question is asked solid angle delta. So area of this one is 1 centimeter square. So saturated symmetrically at the distance of 5 centimeter. So at the distance of 5 centimeter symmetrically. So now the question is asked. So angle, solid angle. So solid angle is equal to area divided by r square. So then the solid angle delta. So the solid angle delta is equal to area. So area is 1 centimeter square divided by radius is 5 square centimeter square. So now that is 1 divided by 25. So that is the solid angle is equal to 0.04 steradian. So now the final answer is equal to 4 into 10 to the power of minus 2 steradian. So which is the answer is matching for this one. Okay, so this is the option C is the matching for this one. Option C is the correct answer for this question. The value of the resistance is equal to 10.845 ohm and the current is equal to 3.23 ampere. So on multiplying we get potential difference. So potential difference 35.02935 volt. So now the question is asked, the value of potential difference in terms of significant figures. Okay, so what is the value of this one with the significant figures, the correct significant figure? Okay, so let's see, that is the V is equal to I into R. This is according to the what? Ohm's law. So now, so this is the accurate significant figure. The accurate significant figure is 3 because the current is 3. So the correct significant figure is 3 is the correct significant figure. So now the potential difference, the question is potential difference with in terms of current significant figure. So potential difference is given this much. Then the correct significant figure, the correct significant figure is 3 is the correct significant figure. 1, 2, then it is 0.3. So the correct potential difference with significant figure is equal to 35.0, 3 significant figures. 3 significant figure. So 35 volt, not 35.0. That is option B is the correct answer. This is not wrong. Okay, so that is the answer. So if X and A stands for distance, then for what value of n is given in the equation dimensionally correct? So let's see the solution. So this is the given equation. So in this equation you have to find out the n value. What is the n value? Okay, what is the n? So V, that is A, we know that from the equation that is A square minus x to the power of n is constant. So then according to the principle of homogeneity, that is x to the power of n is equal to A square. So now therefore n is equal to how much value? N is equal to 2. So that is option B is the correct answer for this question. So a physical quantity Q is found to be depending on the observable x, y and obeying the relation Q is equal to x cube y to the power of square divided by z. The percentage error in the measurement of the x, y, z are, so that is x percentage is this much, y and z. So what is the percentage of error in the quantity of Q? Okay, so now that is delta Q divided by Q into 100%, that is equal to 3 delta x by x into 100 plus 2 into delta y by y into 100 plus 1 into delta z divided by z into 100. So now the percentage of error in the Q quantity is, that is equal to 3 into, so what about this percentage of the x? Okay, the percentage of the x is 1% into 1% plus 2 into, so delta y by y into 100 is how much? 2% plus delta z by z is how much? 4% into 1. So now after the simplified, 3% plus 4% plus 4%. So the final answer is 11% of error. So error in the quantity of Q. So that is option A is the correct answer for this question. So in the measurement of the random error, so the measurement of the random error. So what is the meaning of the random error? Okay, so random error means what? So random error is, what is the random error? So in the same measurement, a number of times is took, and then average value of all the observations, that is what? Random error. So that means, for example, this is the experiment. In this experiment, you take the number of trials, trial number 1, trial number 2, trial number 3. So take the average, trial number 1 plus 2 plus 3, then how many trials are there? You have to take that numbers, average of this one. That is the random error. So can be decreased by increasing the number of readings. Okay, so the measurement of the random error can be decreased. Okay, this error is decreased by increasing the number of readings and average them. Okay, this is the correct. Can be decreased by using the new instrument? No. Can be decreased by using the different method of taking the reading? So can never be decreased. So that random error is decreased. How can be the random error is decreased? The random error is decreased by, okay, so decreased by taking the number of trials, then after average it. Okay, so that is the random error. That is option A is the correct answer for this question. The number of particles crossing per unit area perpendicular to the x-axis in the unit time. So that is n is equal to minus d into minus n1 divided by x2 minus x1. So n means what? N is the number of particles crossing per unit area. So per unit area, area dimensional formula is L square is the area. Per means minus. Okay, per means minus. Then per unit time means t to the power of minus 1. Then that is equal to d is constant, n. So where n1 and n2 are the number of particles per unit volume. Okay, that is the per unit volume, that is L cube is the unit volume divided by x1, x2 are the values, that is L. So then you have to find out the dimensional formula for D. You have to find out the D dimensional formula. So then D is equal to what? D is equal to L square T to the power of minus 1 into L divided by L cube. So then the dimensional formula for D, M is not there, 0, L to the power of minus 1, so L cube and L, it is L to the power of minus 2, this is a L cube means per unit volume means minus, okay, this is minus, then T to the power of minus 1. Okay, so this is the dimensional formula because it is a per unit volume, so per means it is minus. So which is the option is matching for this answer? So M0 L plus 2 T minus 1, that is option D is the correct answer for this question. So the distance of a galaxy is in the order of 10 to the power of 25 meter. Okay, the solution. So the distance of the galaxy, that is a distance. So distance is equal to how much? 10 to the power of 25 meter. So calculate the order of magnitude of time taken by the light to reach us from the galaxy. You have to calculate the time to reach from the galaxy. Okay, light. So what is the speed of light? Okay, speed of light is, we know that value, that is a speed of light is equal to 3 into 10 to the power of 8 meter per second. So now speed, distance is given, time. We know that speed is equal to distance divided by time. Then time is equal to distance divided by speed. So then distance is how much? Distance is 10 to the power of 25 divided by speed is how much? 3 into 10 to the power of 8. So then time is equal to so 1 by 3 into 10 to the power of 25 minus 8. So 25 minus 8, that is T is equal to 0.33 into 10 to the power of 17. So then the T is equal to 3.3 into 10 to the power of 16 second. So it is in the order of, the time order is how much? The time order is equal to 10 to the power of 16 second. So which is the option is matching for this one? Option A is the correct answer. But the many students are put the value of 10 to the power of 17. So this is the wrong. You have to, the decimal point is shifted up to the 2 significant figure. Okay, that is a 2 significant figure. So then that is the option A is the correct answer. Okay. The displacement of the progressive wave is given. So let's see the solution. The displacement wave of the progressive is A sine omega t minus kx. That is called as the displacement of the progressive wave, where x is the distance and t is the time. So what is the value for this one? Okay, so that is the omega divided by k is equal to, what about the dimension formula? Okay, so first one is omega t, it is a constant. So then that is a omega is equal to 1 by t, that is equal to t to the power of minus 1. Then similarly k, it is kx. Similarly kx is constant. Then kx is equal to 1 by x, that is equal to, x is the distance. Distance means it is a L to the power of minus 1. So now put the values on this equation. So that is omega divided by k is equal to omega is t to the power of minus 1 divided by k is L to the power of minus 1. So then after the simplified, that is t to the power of minus 1 L to the power of plus 1. So which is the dimensional formula? L means what? It is a meter, measured in meter, minus divided by second time. So meter per second, that is a velocity. So now the answer for this question is velocity dimensional formula. I got it is here. So that is option A is the correct answer for 16th question. So K is the kinetic energy, V is the velocity, T is the time. If they are chosen the fundamental units, then the dimensional formula for surface tension. Okay, so what is the surface tension? We know that surface tension is equal to energy divided by area. So that energy means, energy is the work done divided by area. Then the work done dimensional formula is, work done is force into displacement, mass into acceleration, into displacement is L, divided by area is L square. Then the surface tension dimensional formula is M L to the power of 2 minus 2. This is a cancelled each other, that is a L to the power of 0. Then T to the power of minus 2. That is the dimensional formula for surface tension. Okay, next one. So the surface tension is, okay, the surface tension is directly proportionality to the what? Kinetic energy, velocity and time. So that is the surface tension dimensional formula. Surface tension is, S is the surface tension, that is equal to kVt. So surface tension, k to the power of, okay, k to the power of x, y to the power of y, we don't know, z to the power of z, t to the power of z. So the surface tension dimensional formula is m to L to the power of 0, t to the power of minus 2. This is the surface tension dimensional formula. That is equal to K. K means what? Kinetic energy. So what is the dimensional formula for kinetic energy? The kinetic energy is equal to half m square. Okay, half m square. So the dimensional formula is m L2 t minus 2. That is the dimensional formula for kinetic energy. Then velocity time. So kinetic energy dimensional formula, I got it here, m1 L2 t minus 2. So that is m L2 t minus 2. That is the dimensional formula for kinetic energy. This is power is x. velocity is L t minus 1, that is the dimensional formula is y. So t to the power of what? Z. So according to the principle of homogeneity, okay, so according to the principle of homogeneity, okay, according to the principle of homogeneity, you have to powers, that is m L to the power of 0 t to the power of minus 2, that is equal to, so m to the power of 1 into x plus 0, only x. So then L to the power of 2 into x, 2x. So 1 into y plus y, then it is 0. So L to the power of 2x plus y. Then t to the power of, okay, t to the power of minus 2x minus y plus z. So that is the dimensional formula for t. So comparing the powers according to the principle of homogeneity. Okay. So comparing the powers, we get the answer. So x is equal to how much? X is equal to 0. Then L. So 2x plus y. 2x plus y is equal to 0. Then the y is equal to how much? So the y is equal to, okay, so that is x is not 0. Let's see, x is equal to how much? So m to the power of 1, that means x is equal to how much? X is equal to 1. Okay, x is equal to 1. Then 2x plus y is equal to 0. Then 2 into, that is a y is equal to minus 2. Okay, y is equal to minus 2. So then 2x means minus 2. Okay, minus 2, this equation minus 2, x value is 1 into minus 2, minus into minus plus y value is 2 into 1, 2 plus z is equal to t to the power of minus 2, that is equal to how much? Minus 2. You have to comparing the powers, this power and this power, this power and this power, this power and this power. So plus 2 minus 2 get cancelled, z is equal to minus 2. So I got the answer. So all these three values, okay, all these three values. So that is the surface tension is equal to k to the power of x means 1. Okay, then second one, v to the power of y. So v to the power of y value is minus 2. Then t to the power of z is minus 2. So the final answer is the surface tension is equal to k to the power of 1. So v square, v to the power of minus 2, t to the power of minus 2. Okay, k to the power of 1, v to the power of minus 2, and then t to the power of minus 2. So which is the answer is correct matching? So that is option B is the correct answer for this question. Question number 18. If 3.8 into 10 to the power of minus 6 is added with 4.2 into 10 to the power of minus 5. So give the result. What is the insignificant figure? So this is 10 to the power of minus 5. This is 10 to the power of minus 6. You have to convert 3.8 into 10 to the power of minus 6. Then it is how to convert 10 to the power of minus 6 into divided by 10 and multiplication with 10. Okay, so then 10 into 4.2, 42. 10 to the power of plus 1. So it will be shifted to the numerator, that becomes 10 to the power of minus 6. So then the final answer is 42 3.8 45.8 into 10 to the power of minus 6. It is 10 to the power of minus 6 is common. Add 3.8 plus 42. Okay, 42 plus 3.8 is 45.8 into 10 to the power of minus 6. So the result is 10 to the power of minus 5. So now the result is converted into 4, okay, into 10 divided by 10. So now this is 1, okay, dividing by 10, that is a 45, that is a 4 point, okay, 4.5 4.58 into 10 to the power of minus 5. So according to the significant figure, giving the regarded significant figure. So in the round up, okay, round of the first decimal point, so that is equal to answer 4 point. This is a 5, next digit is 8, it is above 5, that is a 6. 4.6 into 10 to the power of minus 5. This is the answer for this question. 4.6 into 10 to the power of minus 5. The most of the students are, okay, so you have to take the answer for A. This is not correct according to the significant figures. Okay, you have to round up the number. Okay, round up the number after the decimal point, depending upon the what you have to options are there. The velocity of water waves may depend on their wavelength, density of water, and acceleration due to gravity g. The method of the dimensions formula relation of these quantities. Okay, so let's see the solution. The velocity, okay, the velocity is depending upon directly proportionality to the wavelength, density, and acceleration due to gravity. So then the velocity is equal to, okay, velocity is equal to wavelength, density, g. So this is power is unknown, x, y, and z. Okay, so this is the equation. So the dimensional formula for velocity. Okay, so what is the dimensional formula for velocity? The dimensional formula for velocity is meter per second. So that is m to the power of 0 is equal to wavelength. Okay, the wavelength dimensional formula. Wavelength is L. So L to the power of x. Then, so what is the dimensional formula for density? Okay, the density dimensional formula, density is equal to mass by volume. Mass by volume, that is equal to m L to the power of minus 3. That is m L to the power of minus 3 whole to the power of y. Then acceleration due to gravity, L t minus 2. That is whole to the power of z. Okay, so then, so that is m to the power of m to the power of m to the power of 0, L to the power of minus, that is 1, L to the power of 1, then m to the power of, okay, y, then L to the power of x minus 3y plus z, 1 into z, then t to the power of minus 2z. So comparing with the principle of homogeneity, m. So y is equal to how much? Y is equal to 0. Then minus 2z, this is minus 1, t. So minus 2z is equal to minus 1. Then z is equal to minus get cancelled. Z is equal to 1 by 2. Z is equal to 1 by 2. Then put z and y value. X, so in this equation, this is a power is 1. X minus 3 into y value is 0 plus z value is 1 by 2, that is equal to how much? 1. So then x is equal to 1 minus 1 by 2, that is equal to 1 by 2. X is equal to 1 by 2. So x is 1 by 2, y is 0 and z is 1 by 2. So put all those values on equation number 1. So equation number 1 becomes V, that is velocity, is equal to density x. X means 1 by 2, then wavelength 1 by 2, density is y is 0, acceleration due to gravity z 1 by 2. So that is k is a constant, it is a proportionality constant. K is a proportionality constant, no confusion. K is called as, it is a proportionality constant. It is given in the options, that is the reason I put is here. Otherwise, in the last problem, I cannot put the proportionality constant because in the options is not given k. Okay, so next one, that is a velocity is equal to k is as it is, wavelength is 1 by 2. Okay, wavelength is 1 by, it is a squaring on both sides because it is option is square. Okay, now let's see the squaring on both sides. So squaring on both the side, that is a square, V square is equal to k square lambda. Okay, 1 by 2 1, it is 1. Then 0 means it is 1, and acceleration due to gravity is 1. Okay, so this is the answer. So let's see which is the option is correct for this one. That is a k square. Okay, k square. K means it is a proportionality constant. You have to k is as it is k lambda g. Okay, k lambda g. That is a option B is a correct answer. Okay, that is option B is the right answer for this problem. The respective number of the significant figure. So this is 23.023. So how many significant figure? 1, 2, 3, 4, 5. Because it is all those are number, that is the reason it is a 5 significant figure. Then 0.0003. This number is lesser than 1. Okay, this number is lesser than 1. That is the reason you have to, there is no significant figures this side, only one significant, that is a 3 is a one significant figure. The 1 is a only one significant figure. Which one? 3 is a only one significant. These are not significant figures. Okay, next. So these are the not significant figure. Then the third one, 22.1 into 10 to the power of minus 3. So in this, it is 10 to the power of minus 3 is a not significant figure, only 2 significant figure. So the answer is 5, 1, 2. So 5, 1, 2. This is 5, 1, 2 are the significant figure. That is the option B is the correct answer.